Hello again, students. So I'd like to start in today on proving more complicated trig identities than what we've done in the past, and I want to introduce another technique to solve to prove trig identities. So let's even just start with one more example. Let's try to prove involved trig identity. Let's try to prove the identity that cosine of alpha times 1 minus the sine of alpha is equal to 1 plus the sine of alpha divided by cosine of alpha. So the strategy we've been doing so far has involved just taking the side that's more complicated, because that has the most space to simplify, and simplifying until we get down to the side that we're interested in. Well, if you look at this, there's not an obviously more complicated side. So I guess that means I should be able to just pick one arbitrarily and do what I want. So I'll pick the left-hand side arbitrarily. You might pick the right-hand side. So cosine of alpha divided by 1 minus sine of alpha. Let's see what we would like to do to turn that into, to simplify it, and more generally to just turn it into this thing. So I don't see any obvious simplification. There's no cancellation. There's nothing useful that I see. But if you look at this side, well, let's just compare and contrast. I see a 1 plus sine of alpha in the numerator. So let's try to put a 1 plus sine of alpha in the numerator. And how can you put a 1 plus sine of alpha in the numerator of something? Well, you multiply by 1 plus sine of alpha. But if you multiply by 1 plus sine of alpha, and you want to actually have equality, you also need to divide by 1 plus sine of alpha. So I will multiply and divide by 1 plus the sine of alpha. And what will that give me? That will give me cosine of alpha times 1 plus the sine of alpha divided by 1 minus sine alpha 1 plus sine of alpha. So if you like, that's the opposite of simplifying. I've just made it more complicated. So let's look at that and see what happens. So you might be really, really tempted to see that piece and say, oh, well, those cancel. I can cancel them. But that will just be undoing what we just did. That wouldn't get us anywhere useful. So that's a bad move to make. Instead, let's look in the denominator. Looking in the denominator, I see 1 minus sine of alpha, 1 plus sine of alpha. Let's distribute and see what happens. Well, that will give me, the numerator is not changing, cosine alpha, 1 plus sine alpha. And in fact, I don't want to change the numerator, because the numerator, I see a piece that I want. I want this 1 plus sine of alpha there. I don't want to distribute that cosine of alpha through, because that would just muddy the waters. It would make it harder for me to get back to that 1 plus sine of alpha. That is my goal. In the denominator, though, what do we get when we distribute? We see 1 outside, plus sine of alpha, inside, minus sine of alpha, so those two will cancel, minus sine squared of alpha. 1 minus sine squared of alpha. So you'll notice that I'm claiming that the Pythagorean identity is what I'm going to use. Let's go ahead and see what I mean by that. So the Pythagorean identity says that the cosine squared of alpha plus the sine squared of alpha is always equal to 1. But notice, you could write that in different ways. You could rewrite this as saying cosine squared of alpha is equal to 1 minus sine squared of alpha. So let's use that version of the Pythagorean identity to get something. We get, the bottom is now cosine squared alpha. In the top I see cosine alpha 1 plus sine alpha. Oh, well, check it out. In the numerator, I see multiplication by cosine alpha. In the denominator, I see multiplication by cosine of alpha. So they'll cancel, leaving me with 1 plus sine alpha divided by cosine alpha, which is exactly what I was aiming for. Okay, that's exactly that side. So that completes the proof. So there's one way to prove a thing. You can prove an identity by taking one side of the identity that you think is true and doing some algebra, simplifying that side of the equation, and hopefully getting down to the other side of the equation. There's another philosophy you can have, though, and that's the philosophy of manipulating the whole equation at once. So if I change the whole equation by, say, adding a number to both sides or multiplying both sides by a number, I'll resolve the equation if I can take the equation that I start with and transform it to an equation that I know is true. Then I'll know that the equation I have is true. So let's try that philosophy on this same one. And this is a good approach to take sometimes when there's not an obvious choice of which side of the equation is simpler. So let's try to prove the identity cosine of alpha divided by 1 minus sine of alpha is equal to 1 plus sine of alpha divided by cosine of alpha. So let's start with the original equation. The original equation is cosine alpha divided by 1 minus sine alpha is equal to 1 plus sine alpha divided by cosine alpha. And I see a fraction on both sides of that equal sign, and those two fractions kind of make it hard to walk with. It would be simpler if there weren't fractions. I would rather see multiplication than division. Well, I know how to get rid of those fractions. I will clear the denominators by cross-multiplying. If I cross-multiply, I will now have cosine alpha times 1 plus sine alpha, 1 plus sine alpha. Cool. So the left-hand side is now cosine squared of alpha. The right-hand side you can compute by distribution, or if you like, by the difference of squares formula. You'll get that the right-hand side is 1 minus sine squared alpha. If we add sine squared to both sides, we'll end up with cosine squared of alpha plus sine squared of alpha is equal to 1. Hey, cool. So we've just taken the identity that we started with, the thing that we wanted to prove. We've reduced it down to the Pythagorean identity. We know the Pythagorean identity is true. So since the Pythagorean identity is true, the identity we wanted to prove must be true. And there's a proof of the identity that cosine divided by 1 minus sine is always the same, as 1 plus sine divided by cosine. Cool. So this gives us a second strategy to prove trig identities. So what are the two strategies? Strategy one is to manipulate the more complicated side. Until it becomes the simpler side. The second strategy is to manipulate the whole equation until it becomes a known identity. So let's try to use these strategies to do this. So the remainder of this document consists of a few more identities, that many more, that I encourage you to go through on your own and come up with your own proofs before viewing the rest of this video. So take a moment, go and do that. I don't know, it should take like 30 to 45 minutes. Awesome, so you've done that. Let's come back and let's talk. Let's prove 1 plus tangent psi divided by 1 plus cotangent psi is equal to the tangent of psi. There are two good ways to do this. Well, you could use either strategy. There's one side that obviously looks more complicated. You could simplify that down to the left-hand side. On the other hand, you could simplify the whole equation all at once. So I'll use both strategies. So that means I'll have to manage my space carefully. So strategy 1. So let's take the more complicated side and simplify it. So the more complicated side is obviously this one. So let's start with that side and simplify it. 1 plus tangent psi divided by 1 minus tangent psi equals, and now we need to simplify, 1 plus cotangent, sorry. There, now I've actually copied it down correctly. So the first thing that I notice anyway that we can do is I know what tangent is and I know what cotangent is. So let's use that. So the numerator now becomes 1 plus sine psi over cosine psi divided by 1 plus cosine psi divided by sine psi by expressing in terms of sine and cosine. Cool. So now look at this for a moment. I see 1 plus a fraction in the numerator. Right? There's 1 plus a fraction. I see 1 plus a fraction in the denominator. I know how to add 1 to a fraction. I need to get a common denominator and then add fractions. So the numerator, that 1 I will write as cosine psi over cosine psi plus sine psi over cosine psi divided by sine psi divided by sine psi plus cosine psi divided by sine psi by getting common denominators. And there's an obvious step that should always follow the step where you get common denominators, and that's adding fractions. Spelling is hard. You will have to forgive that. So let's add those fractions. So in the top I see cosine plus sine divided by cosine. Cosine psi plus sine psi all over cosine psi all over sine psi plus cosine psi all over sine psi. Well, great. Again, more than one way to go about these, but maybe as the next step that I'll follow, I see a fraction divided by a fraction. So whenever you see a fraction divided by a fraction, you know what you have to do. You need to multiply by the conjugate of the denominator. What am I saying? Not conjugate, that's the wrong word. Reciprocal, silly. Alright, well doing that, I see cosine psi plus sine psi divided by cosine psi multiplied by sine psi divided by sine psi plus cosine psi. I see some things that cancel. I see that this and this are the exact same thing. One is in the numerator, the other is in the denominator, so they cancel. That leaves me with sine psi divided by cosine psi, which, hey, that's the exact same thing as tangent of psi. Re-expressing in terms of tangent. So there's one proof of this identity. Let's do another one. So that's the proof that maybe you came up with by simplifying the more complicated side. Let's also try to manipulate the whole equation. So, let's do that. Starting with, and now I'll just write down the equation that we want to prove. I want to prove that 1 plus tangent psi all over 1 plus cotangent psi equals tangent of psi. So there's the thing that I want to prove. and we'll do it by manipulating the whole equation. So one thing that you notice is I see a fraction on the left-hand side. So that should give you a hint that maybe it's while clearing denominator. By, let's see, this is multiplying both sides by 1 plus cotangent psi. We see, maybe parentheses are nice there. All right, everything's being multiplied by that. 1 plus tangent of psi equals tangent psi times 1 plus cotangent of psi. All right. So I want to make the left and right hand side look the same. And let's see imagine what would happen if we were to distribute this. Sorry, that's the wrong button. If we were to distribute this out, right, then I would see a tangent times 1 plus a tangent times cotangent. So I at least see this tangent, which would be what we want on the other side. So let's do that. By the distributive law, we see 1 plus tangent of psi is equal to tangent of psi plus tangent psi cotangent of psi. And some things to notice. That makes me happy. I see tangent equals tangent. Tangent and tangent, those are good. Now I just need 1 to be equal to tangent times cotangent. Why should that be true? Well, I know what cotangent is in terms of tangent. So let's see, because cotangent psi is equal to 1 over tangent of psi, right? It's the reciprocal of tangent. We get 1 plus tangent psi equals 1 tangent of psi, right? Plus 1, which is true. As we have reduced 1 plus tangent psi over 1 plus cotangent of psi equals tangent of psi to a true statement, we have proven 1 plus tangent of psi over 1 plus cotangent of psi equals tangent psi is an identity. Cool. So there are 3 more left. I think this is as good a place as any to break this video and get it uploaded. I will see you in the next one, in which we'll talk about the remaining items in this list. See you soon.